How would you make 2-methyl 1-amino cyclohexane from cyclohexanone? Well, let's go ahead and look at where the carbons are. This carbon, most likely, is going to be this carbon. Let's see if we can think it through. Well, if I look at this, I know I could put a methyl group on here by doing alkylation. So I could, this could be one of my intermediates. Is there a way from this for this to get here? Oh, remember, we can do reductive amination. Yes. So how is it I go from cyclohexanone to methyl cyclohexanone? I use lithium diisopropyl amide and methyl bromide. How is it I go from this to this? I treat it with ammonia and catalytic acid, and then sodium cyanoborohydride to reduce the imine. How do you make benzylamine from toluene? Well, here's toluene and here's benzylamine. I see I have to derivatize this. How could I do that? Well, I could brominate. If I brominate, what could I do? I can't treat it with ammonia because I would get multiple alkylations. So what do I use? I can get the azide derivative and then reduce it. So how do I go from toluene to benzyl bromide? Well, I just use NBS and light. How do I go from benzyl bromide to the azide? I just use sodium azide and a good solvent. How do I go from sodium azide to the amine? Lithium aluminum hydride reduces it. So how do you make how do you make this amine from cyclopentadiene? Well, here's cyclopentadiene. You look at this and you say, oh wow, these must be these carbons, right? Because if I do a Diels-Alder, I could put a double bond here and then that nitrogen's right there. This is kind of a hard synthesis. It's going to be a lot of thought involved here. But let's just look and see. I know I can do this. I have to have on my diene, remember, I've got to have a carbonyl. I could have put an aldehyde here. I could have put a carboxylic acid. There's a lot of things, but I know I can do a rearrangement with this. So let's start with this. That's going to give me this amine. Notice I have the carbonyl group down because this is up, and the endo is what would be selected. Notice this is down also. Now what can I do? Well, I can treat this amide with something that would cause it to form the isocyanate and then do the rearrangement. Here we go. Sodium hydroxide and bromide is going to derivatize this, turn it into the isocyanate, and then the water would hydrate it and decarboxylation would occur. So we would get this amine. How can you make 3-phenyl-1-butene from 3-phenyl-2-butanol? Well, here is the 3-phenyl-2-butanol, and here's 3-phenyl-1-butene. Notice I can't do dehydration. It would give substitution right here. Elimination to form the alkene here, which is most highly substituted. I've got a less substituted alkene. Well, that means I have to use an amine to do tetraalkyl ammonium elimination. Okay, how do I get this? Well, because that's a secondary carbon here, I'm going to need to use reductive animation from the ketone. Let's look at what reagents I can use. To go from here to here, I'm just going to oxidize. And any oxidizing agent could work. This will be a good one. I then would treat this with ammonia and sodium cyanoborohydride. Once I get the amine, then I'm going to treat it with something like methyl iodide and the silver oxide, and that will give me elimination to the less substituted alkene. So how can you make p-butyliodobenzene from nitrobenzene? Well, here's the nitrobenzene, and here's p-iodobenzene. Well, I'm looking at this, and I'm remembering that if I have an iodine substitution, I can get by using the Sandmeyer reaction. And to do that, I'm going to need to have an amine. So I'm going to have to get the nitro group into an amine. And to get this butyl group there, I could do a Friedel-Crafts alkylation or acylation to do that, but I can't do it with this right here. Somehow I have to get that on there. How am I going to get from here to here? Well, I'm going to have to protect that amine group with an acyl group, and then I will be able to take it from here to there. So let's look at and see what the reagents are that I need for each. To go from the nitro group to the amine group, I need to have reduction. What can I use? Lithium aluminum hydride would work, but there's other reagents you might have selected, like tin 2-chloride and acid or hydrogenation. To take the amine to the amide, I need the acyl chloride, and then I can do a Friedel-Crafts to get this acyl group on. So here I've got the acid chloride to change this to the amine, and then here Friedel-Crafts will add this acyl group. Now to get from here to the alkyl aniline, what do I need to do? I need to cleave this. If I cleave that, I can use just sodium hydroxide or acid to hydrolyze this, and then I need to reduce that. So what did I choose? Potassium hydroxide and water. Hydrogenate, that would cleave this off and give you the amine. Then hydrogenation would change this. Remember, when you have carbonyl adjacent to a benzene ring, you will reduce it down to a methylene group, not to an alcohol. And then treating it with water would release all the rest of this, just a water wash. You could have left that off. Now I need to take this and change it to the iodide. How do I do that? Well, I have to use a diazonium salt. So I form the diazonium salt by treating with nitrous acid and sulfuric acid, and then I treat with sodium iodide. Phase transfer catalysts are very important in organic chemistry and in biochemistry. This is both organic and aqueous soluble because the alkyl groups make it want to go into the organic portion, and the salt portion makes it want to go into the water portion. This often can be used to pull an anion like cyanide or some other anion into the organic portion when you can't get it in otherwise. Here's an example. Cyclohexane will not react with sodium hydroxide in water because sodium hydroxide is not going to go up into chloroform. Water and chloroform do not mix, and the sodium hydroxide is not soluble in this. So if you add benzyl triethylammonium chloride, what happens now is the chloride and the hydroxide can exchange. The sodium is not going to go up into solution, but the benzyl triethylammonium hydroxide can, and it pulls it up into solution. So here we have an alkene, and there's our chloroform, and what we're doing is we're treating this with sodium hydroxide by pulling it up with a quaternary ammonium salt. Hydrochloric acid is removed from this and it forms a carbene, and then look, we get a cyclopropane. The transfer is like this. You have this hydroxide up here, and chloroform is heavier than water, denser than water. So you have the hydroxide up here, and it's not going to go down there. No reaction occurs. You add this quaternary ammonium salt, what happens is the chloride and the hydroxide get exchanged back and forth. So now you have this goes down into solution, and now this can remove hydrochloric acid from this in the carbene form to add across the double bond. Phase transfer catalysts can make nucleophiles more reactive because they're naked. They can't hold in real tightly because this nitrogen has a lot of groups around it. So if I use a phase transfer catalyst, this cyanide is held as a counterion on this, but it's kind of naked, and so it's much more nucleophilic, and the reaction goes faster. And not only that, then the cyanide is up in the toluene, and it's not going to be hydrogen bonded by the water. It undergoes nucleophilic attack very quickly.